Become friends. Let us have another short lecture on another special diode called photodiodes. Photodiode converts the light energy into electrical energy, which is opposite to light emitting diode. The photodiode uses the special photosensitive semiconductor material. The photonic light energy induces the minority charge carriers in reverse bias PN junction. So in this diode, photodiodes are normally operated in reverse bias and they are having wider junction region. They are having a special construction arrangement from that there is a window from which the light will be entered and fall on the PN junction. Whenever the light falls on it, the photons of the light give energy to the valence electrons in the active region around the junction. Due to that, the electrons are jumped and available in the conduction band. And that's why, due to applied photonic energy, the charge carriers are available, and due to reverse bias, they will be stripped of this photodiode, and the current is flowing in a external circuit via the diode. The current is proportional to applied intensity of the light. Let us see the construction. See here, there is p-type material, there is n-type material, and it sandwiches a intrinsic layer of a semiconductor, photosensitive semiconductor material, whereas p-type material is having a translucent area and a window each on that side. From this window, the light will be incident on the p-type material. This another figure shows the two-dimensional figure. Now here let us see the operation. Whenever the light falls in the active area of a photodiode around the junction, it induces the charge carriers due to photonic energy. And the reverse voltage applied across this PN junction cause this induced current to flow in the outer circuit. A typical this photodiode symbol is shown here. You will see the light is shown going inside. As compared to LED, in LED symbol, the light is coming out, whereas in photodiode, the symbol, the light is going inside, and that causes the current flow. A typical characteristic of the photodiodes are shown here. When no light flows, ideally speaking, there should be no current. Whereas in practical diodes, very small current is flowing due to thermally generated minority charge carriers. This current is also called as dark current. When the intensity of the light is increasing, the photonic energy is increasing, and therefore current carriers induced in the photodiode increases, and that gives rise to larger current through the photodiode. Typical VI characteristic with different lumen intensities are shown in the characteristics. For 25,000 lumen per meter square intensity, you will see the current is reaching to around 360 microampere. If the intensity is decreased to 10,000 lumen, the current is decreased to 100 0.1 microampere, whereas earlier it was 0.36 microampere, means it is in nanoamperes. The material used for photodiodes. A typical material: germanium, indium arsenide, antimony, indium gallium arsenide, mercury cadmium telluride. These materials are more sensitive and therefore dark current is more. Whereas silicon, gallium phosphide, and extended range of gallium arsenide photodiodes, they are having low dark current because they are less sensitive to the temperature. Different types of photodiodes are shown here. A PN junction photodiode is shown, whereas PIN photodiode is shown, in which I indicates the intrinsic layer between P and N, which widens the area of or active area where the charge carriers are generated. Avalanche photodiode is also shown here, which also consists of a additional P plus layer and intrinsic layer. Applications of photodiodes. Photodiodes can be used in compact disc player called CD players. They can be used for smoke detectors. They can be used in space applications. They can be used in the medical applications like computerized tomography called CT scan. They can be used in sample analyzers, pulse oximeters. So they are used as light sensors or light detectors. They can be used in optical communication like fiber optic communication. They can be used as light intensity sensors in cameras. They can be used as a basic sensor in light intensity meter. Their application found in object counter also. A comparison of various PN junction diode is shown here in a table. We have seen an ordinary PN junction which is used for rectification purpose. We have seen a Zener diode which is normally used in breakdown region for voltage regulation purpose. The another special purpose diode is light emitting diode, which is normally used in forward bias, which emits the light. And the another diode we have seen is a photodiode, which can be generating a current when the light falls on it. Various comparison parameters are shown here. So that's all about the diodes. Thank you. Bye bye.